we are driving home these exponential and logarithmic functions. Let me tell you, they are prominent. They get used prominently as models for different scenarios in the business world. It's just what gets used. Here they want the first derivative of this function r of x given to us as 3 to the power of x to the power of 9. Note that this does not say 3 to the x to the 9, because if it did, you would be reading it as 3 with an exponent of x to the 9. And they would have different derivatives because they're different functions. Since it does not say that, why would we do this the hard way? You know, this is the same, according to our exponent rules, this is the same as 3 to the power of 9x. Right? So you have an f of star, which is 3 to the power of star, and you have a g of x, which is 9x. Well, you know how to do g prime, but how do you do this? We know how to do e to the star. It would just be e to the star. But that's not e, that's 3. Well, turns out it's not too bad. You sort of already have been doing it the general way. It works like this. If you have some function that's an exponential function, then the derivative of that function is that function times the natural log of the base. Maybe I should have used a b for base. B for base. See that this coincides with, if you had the exponential function, then you would find its derivative by having that base to your exponent x, and then times the natural log of that base. But natural log of e is the number 1. So this just equals e to the x, because natural log of e is 1. Okay, then back over here on our problem, f prime of this star would have been that same stuff times the natural log of 3. And g prime of x is just 9. So r prime of x is nothing more than f prime evaluated at g times g prime. So you'd have 3, and then up here we're going to put g. That's 9x, except I'm not going to use parentheses. And then you'd have your natural log of 3, and you'd have your 9. So do I see my answer? It's right there. Okay. Easy problem. 3 times 5 to the x. Do not say to me that this is 15 to the x. Okay. It is not 15 to the x. It is 3 times this function, and this function is 5 to the x. You don't even need a chain rule to evaluate this function. G prime is just 3 times the derivative of 5 to the x. Well, that's going to be 5 to the x, natural log of 5. So maybe you see it like 5 to the x times 3 natural log of 5. There is a bunch of different ways, you know, that you could change this writing according to your logarithm rules or whatever. So we will just leave it like that and see that it's this one. Okay. I would hypothesize here that in this homework there's going to be some logarithm business to deal with. And if you don't know your logarithms, it may be time to have to learn it finally. This is just like our first problem. P of x is this function 8 to the power of x raised to the 7. This is the same thing as 8 to the power of 7x. So P prime of x is what? We need the derivative of 8 to the star. Here, let's write it. So this looks like f of g of x for f being 8 to the star and g being 7x. Then P prime has got to be the product of two derivatives. Right? Where I'm going to replace the star with g of x. So I'd have 8 star natural log of 8 and then times 7, because that's P prime. And then I'll kind of backtrack here and replace my star with g of x, which is 7x. Okay. Cool, these aren't so bad. Same thing here, it's the function 7 to the power of 4x. There's our answer. Okay, here we go. So now there's some different logarithm bases than the natural base. But the only derivative that we know is how to differentiate the logarithm when it is the natural base. So you will need to use your change of base formula. Change of base formula is extremely powerful it says that if you have some logarithm with this base and this argument, it is just the natural log of A over the natural log of B. Very handy. So for our problem that was given to us, we had log base 3 of x cubed plus 6x squared plus 3, right? But according to our change of base formula, this is the natural log of x cubed plus 6x squared plus 3 over the natural log of 3. That's our function. We've just modified our function. We have not done the derivative. I would even prefer that you go further and say that our function looks like 1 over natural log of 3 times natural log of x cubed plus 6x squared plus 3. Just to drive home the fact that it is this number times this natural log function. I've done all this writing. I haven't even done a derivative yet. You do all this so that the derivative will be straightforward. You keep your constant. It's just a constant. It comes out front. There's my constant. It's a constant times what? The derivative of this guy. And you know how to do the derivative of that guy because we've been doing it over and over. X cubed plus 6x squared plus 3 in the bottom, and in the top is the derivative of the thing I just wrote, 3x squared plus 12x. Now a 3 will, no it won't, never mind. I was about to make a mistake. All right, that's it. That's our answer. So when I go back over here, then we have, boom, this one. I was going to say a 3 factored out, but that's not true. So they're going to use this. I don't use that. There's not even any reason to use that. Right? It's true, but guess what, y'all? It's just built out of the change of base. If I had the logarithm with some mysterious base, and here I've got, you know, and here's just x, then, and you want the derivative of that, then by change of base, this is the natural log of x over the natural log of b. That's just our function. So when you do derivatives, you get 1 over natural log of b times 1 over x, which is just 1 over x natural log b. Okay. I guess you could go further and say that if I had, you know, you can go further and kind of make this somewhat, I guess, easier. I want this derivative. What does this derivative always need to look like? Well, according to the change of base formula, it will just be the natural log of f of x over the natural log of b. You would inevitably write this as 1 over natural log of b times natural log of f of x before you start the derivative, but that 1 over natural log of b is a constant, so it comes out front, and now you can take the derivative of the natural log of f of x, but that's something that we already know how to do because it's just f prime of x over f of x. If there was going to be a rule somewhere, I'd make it this rule. So, I mean, like this one. Pretend it just says natural log of this stuff. Can you find that derivative here? Yeah, it looks like this one. Also kind of looks like this one, but the natural log of 8 doesn't go on top, it goes on the bottom. Wow, how did it get to the bottom? Well, that's the change of base formula. Same deal here. Not that one, this one. So since I did the last two in a rush, we'll do this one worked out. So f of x is log base 2 of 6x cubed plus 2x plus 6. I want to simplify this one first. Do I? I'm looking at their answer choices. They didn't simplify their answer choice. Why should I simplify mine? They should have simplified their answer choice. So I guess we won't simplify it after all. You could factor a 2 out of all this, right? But if we did that, then our answer choice wouldn't look like theirs, so I don't want to mess with it. F prime, well, let's rewrite f first. If we just know this change of base formula, it makes it to where we're not having to remember a new derivative rule. The change of base formula is something that you need to know for other stuff anyways, so you might as well have it. It's the natural log of 6x cubed plus 2x plus 6 over the natural log of 2. And I prefer you view it as this number times this function. Because then f prime is immediate. It's, well, here's our constant. It just comes out front. And then we have the derivative of a natural log function. Now they should have factored out a 2 from the top and bottom here and canceled it, because I've seen them do that on previous problems, and you know what? They did not do it here because they are hypocritical. There's our mastery. Okay, so the takeaway here was b to the x has derivative that looks every bit the same as taking a derivative of e to the x, but you multiply by natural log of b. And log base b to the x gets shifted around to look like a natural log of x over a natural log of b, taking a derivative, so that we can use what we already know about the derivative of the natural log.